Hello everyone. So today we are going to look at various laws which were given by various scientists which govern the combination of elements to give us the compounds. The first one we have the law of conservation of mass given by Lavoisier. This law states that matter can be created nor can it be broken. Simple, isn't it? So let us try to understand this law of conservation of mass. This experiment demonstrates this law in the best way. A solution of calcium chloride is taken into a test tube and sodium sulfate solution is taken into a conical flask, and the weighing balance is used in order to check the mass. The mass is reported. The conical flask is slightly tilted so that the sodium sulfate solution is leaked into the calcium chloride solution and a reaction takes place. Because of this reaction, there is a formation of calcium sulfate, which is a white precipitate. Now everyone might think, since there is formation of some solid particles, these are the solid calcium sulfate particles, the mass of that solution or overall compound will be increased. But that was not the case, because it obeys the law of conservation of mass. Since it obeys the law of conservation of mass, this mass remains the same. So from this we can conclude that mass can neither be created nor can it be broken. The second law was given by Joseph Proust, and the law is called as law of definite proportion or definite composition. It states that a given compound always contains the same elements combined together in the same proportion by mass, irrespective of its source. If you take a sample of water from ocean and from a spring, and if you extract out the pure water, then you will find that the molecule of water will always have 2 hydrogen atoms and 1 oxygen atoms. There won't be more than 1 oxygen atoms or more than 2 hydrogen atoms in a molecule of water, irrespective of its source, because it obeys Joseph's law. A better example for this is, we take 100 grams of lead and 1.56 grams of sulfur. We will get 11.56 grams of lead sulfide only. If we increase the quantity of sulfur and if we mix them together, we will only get 11.56 grams of lead sulfide. There won't be more than that, and the excess sulfur will be left over. Similarly, if we increase the quantity of lead also, there will be the residual amount of lead which will be left over. This is because it obeys Proust's law. If you try to take 4 hydrogen atoms and 2 oxygen atoms, in order to form one molecule of water, 2 hydrogen atoms among the 4 and 1 oxygen atom among the 2 will combine to give 1 molecule of water. So in total we will get 2 parts of gaseous water. Now you might be wondering, why are we learning this theory, all these laws? These we are learning mainly because based on these laws there are chemical combinations which take place. There are many reactions which takes place, and the elements obey these laws, and because of these laws we are able to predict certain results. Next, going on to Dalton's law of multiple proportion. We know that hydrogen and oxygen gives us two compounds, namely hydrogen peroxide and water. So if we try to see that if we consider only the oxygen part from water and from hydrogen peroxide, if we take the amount of oxygen and from the water molecule and from the hydrogen peroxide, and if we try to calculate the ratio, we will get a whole number. May it not be only for water and hydrogen peroxide. You can take some other compounds which have one common element, and you will find out that the ratio is always a whole number. This is because it also obeys Dalton's law of multiple proportion, which states that if two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. We see in a previous example that the mass of hydrogen is fixed. It is given here that the other element has a fixed mass. So if we try to take the ratio of the first element, then we will always get a whole number. Even for that matter, if at all you all might land up in some quiz show and you are about to win, and if you get a question related to these laws, then you will be able to answer these laws as well. Or maybe you will be able to identify the particular scientist who has given these laws. Next, moving on to the Gay-Lussac's law of gaseous volume. Now we are looking at the laws for gases. This law states that gases at constant temperature and pressure combine in a simple ratio by volume during a reaction. So gases, the word, they should be at constant temperature and pressure. Then only they will combine in a simple ratio by volume during a reaction. This law was better put forth by Avogadro. He said that equal volumes of all gases at same temperature and pressure should contain equal number of molecules. And he gave up an equation which is V1 upon N1 is equal to V2 upon N2, where V1 and V2 are the volumes of gases and N1 and N2 is the number of molecules or the amount of gas. This law can be understood along with Gay-Lussac's law through these examples. This is a typical demonstration of Avogadro's law. There is one volume of hydrogen, there is another volume of hydrogen, and there is one volume of oxygen. We see that in the first box of this gas, there are all in all 10 hydrogens. In the second box also there are 10 hydrogens. And in the last box, there are 10 oxygen. So all in all, there are 20 hydrogens and 10 oxygens. And we know that one oxygen combines with two hydrogens to give a water molecule. So we get total of 2 volumes of water vapor by the combination of 2 hydrogen atoms and 1 oxygen atom. So that's it for the day. Thank you very much, and we will continue with the series and giving you all the glimpse of what is the next part. The next part we will deal with is the calculation of the atoms and the molecules and various other things as well. For any queries, you can leave it into the comment box. Thank you.